I think this video is showing. I think it's recording. I'll see after I upload it. I'm going to officially start at 11 o'clock going over the purple packet. So I'm just going to sit here and wait. Start my phone. Okay, I'm going to get started because if you are anything like me, I've got people at home, no telling who's getting ready to walk in the door. So I want to go ahead and get started. I don't know if you can see this, but I've got my purple packet. Okay, we're going to look at the law of cosine word problems. I'm going to try to get all of these done. That's my goal. I really don't know how long it's going to take, but make sure you have your packet. And let's get started. I also have with me my unit circle. I don't think I'll need that. I have a calculator and I have my flip book so I can get my formulas. All right, let's look. Oh, wait, let me go to, I want to share my application screen. All right, I hope you can see this. My writing on here is not perfect, but I'll do the best that I can. So let's see. Number one, okay, we're on the purple packet. We're on H1. It says law of sines and cosines word problems. All right, so I'm on H1, and that's the name of the packet, and we're going to start with number one on H1. Okay, you have to be looking at your paper to get these word problems. During a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. All right, so let's draw our picture. We've got, okay, here's Jackie and here's Peter. Okay, so this is Jackie and this is Peter. And it says they skate apart. Okay, so like, I guess, this needs to be Peter. Hold on. This is going to be, let's make this B. All right, so this is going to be Peter, and this is going to be Jackie. She spells her name Jacke, and I'm just going to make up that B. All right, they skate at an angle of 15 degrees apart. Okay, so the angle that Jackie and the angle that Pete, is that his name, Peter? Peter, sorry, Peter make is 15 degrees. It says Jackie skates for 5 meters. Okay, so Jackie skates for 5 to this point, and Peter skates for 7. Okay, so they started here. Okay, this is where they started. Jackie goes this way, Peter goes this way. Okay, my picture's not great. So this is there. And the question is, how far apart are the skaters? So we're looking for this length right here. This is what we're looking for. Okay, so I don't like this. Let's get rid of that. I'm sorry. Let me see if I have an eraser. I know there's an eraser, but there it is, eraser. Okay. So let's get rid of that. I don't like that. I don't like that. And I don't like that either. Okay. So let me rewrite my picture. Hold on just a second. Okay, so this is where they start. They're like ice skaters right here, holding hands. Okay, they're holding hands. Jackie goes this direction. This is Jackie. And then Peter goes this direction. This is Peter. Okay, that's a better picture. So think of the little figure skating, you know how they hold hands. And they started out here together. Sorry, let me erase that. And then they go at a 15-degree angle apart from each other. Jackie goes this direction, Peter goes this direction. And the question is, how far apart are the skaters? Okay, so we have to decide if this is side, angle, side, 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 angle, side. Like what postulate is this? So we have a side, then we have an angle, and then we have a side. So it's side, angle, side, S-A-S. And if you look at your flip book from class, we know that S-A-S is the law of cosines. So we're going to use the law of cosines for this word problem. All right, let's go to another, let's go to blue. All right, let's go to blue. Okay, I think it's helpful to label your parts. So if this is angle A, then this is side A, okay? And then this would be like side B, and this would be side C, okay? So for the law of cosines, again, I do not want you to have to memorize a bunch of formulas. But if we are looking for side A, then way down here, we're also going to take the cosine of side A, which is 15 degrees, because side A and angle A correspond. Now let me draw that. This is going to take me way longer than it would in class. So angle A is 15, and what we're looking for is side A. All right, so what we're going to do is we're going to take the other two sides. It doesn't really matter the order. Square the first one plus square the second one minus 2 times the first and the second. And then that is your formula. I'm going to simplify this a little bit. Kaylee said she just straight out put it in the calculator. I just do not trust that. Oh my gosh, that's 25. Sorry. 25. I got ahead of myself. Plus 49 here. Minus, let's see, that would be 70 cosine of 15 degrees. Okay, you don't really have to combine these. I mean, you could, like I'm with her, you can just put it in your calculator, but 74 minus 70 cosine of 15 degrees. Make sure you are in degree mode. Again, at the end, you're going to have to take the square root. We're looking for a and not a squared, so we would have to take the square root of this answer. And what I'm getting on my worksheet is 2.53 meters. These people are 2.53 meters apart, and we use the law of sines to calculate that. That's a good problem. It's not too hard. It's pretty basic, and so we should be able to handle that. All right, I'm going to just pause just a second because I'll have to clear this screen before I can go to the next problem. So that's number 1. Again, what am I doing? I'm on, let's see if we can change to green. I'm on H1. This worksheet is H1, and the name of the worksheet is Law of Sines and Cosine Word Problems. So that's number 1 about Doug and Jackie. All right, I'm going to clear that screen and I'm going to do number 2. All right, cleared that out. Let's go to number 2. All right, refer to your paper. A bridge is supported by triangular braces. If the sides of each brace have lengths of 63, 46, and 40. Okay, so we've got a triangle. It's not a right triangle. I about made it look like a right triangle. The lengths are 63, 40, and 46. It says find the measure of the angle opposite the 46-foot side. Okay, so here's the 46-foot side. We are looking for this angle right here. This is what we're trying to figure out. Now let's label our parts. Right now we have a side, and a side. And so we learned on our flip book, if you have side, 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 you're going to use the law of cosines. Now this one's different because we're going to be solving for the angle instead of the side. The law of cosines. Now this one's different because we're going to be solving for the angle instead of the side. Okay, let's label our parts. I will let this be side A, and I'm going to call this angle A. So I'm looking for angle A, therefore I'm going to use side A when I plug it into my formula. All right, so side A goes here, and then way down here, we're looking for angle A. Now we don't know what angle A is, so I just put cosine of A. All right, I've used 46, so now I square the other two sides minus 2 times one side of 40 and one side of 63. Now the difference here between the other one is that I don't know the angle. I'm solving for the angle, and this is going to require much more work. Okay, so I'm going to get my calculator and I'm going to slowly work this problem out. Okay, let's see. 46 squared. 46 squared is 2,116. 2,116. 63 squared is 39,069. 40 squared is 1,600. And if you multiply all this together, 2 times 40 is 80, times 63 is 5,040 times the cosine of A. Now, we're looking for A. That's extremely important. My next step, I'm going to combine this here. So this is going to be 2,116 equals 5,569 minus 5,040 cosine of A. Now you cannot combine these two. Why not? Because we have to follow PEMDAS. PEMDAS says, please excuse my dear Aunt Sally. This is the last thing we're going to do. I cannot subtract that right here because I've got multiplication. So that's not an option. What I'm going to do instead is move this 5,569 over. It's going to become a negative. And that's going to give me negative 3,453 equals negative 5,040 cosine of A. All right. Next, I'm going to divide both sides by this negative 5,040. Divide both sides by negative 5,040. Because remember, I'm solving for A. This is what I'm trying to figure out. So I've got to do some simplifying before I can deal with that cosine. I'm getting here, if you go to 4 decimal places, point, because a negative divided by a negative is a positive, 0.6851, and that equals the cosine of A. Now, again, we're solving for A. Well, we've already practiced this. What we're going to do to get rid of that cosine is we're going to take the inverse cosine of each side. So we'll take the inverse cosine of each side, and that's going to leave us with A over here because the cosine inverse and cosine will cancel. And I'm getting 46.76, what are we talking about, feet? Okay, so, or no, this is degrees. So this is our angle in degrees. That is the measurement of angle A. Now again, I'm going to pause for a second, give you a minute to catch up with me on that, and then I'll clear the screen out and do number 3. All right, let's clear that out. And let's try number 3. Let's go to, see what color I'm on. All right, number 3. 2 observers are standing on shore a half a mile apart at points A and B. Okay, so 2 people, there's a person here, and there's a person here, and it says they're standing on shore, okay, and they are, what does it say, half a mile apart? Okay, you can do 1/2 or 0.5. I'm going to do that. That'll just make my calculation easier. They see a sailboat at point C. Okay, so here is C, and this is a sailboat. Let's draw a sailboat. There's the boat, and they look at the boat, and they see it at the same time. So this person looks at the sailboat, and then this person looks at the sailboat. Angle A is 63 degrees. Okay, so this is person A, this is person B. So angle C is 63 degrees, and angle B is 56 degrees. It says find the distance from each observer to the sailboat. Okay, so we got to do 2 things here. Each observer. So this is going to be little b because it's opposite angle B. This is going to be little a because it's opposite angle A. And this is going to be C because it's opposite angle C. Now that's important right there. Angle A corresponds to side A. Angle B corresponds to side B. And angle C corresponds to side C. Let me erase those little dots. That's the kind of stuff that bothers me. Okay, let's label what we have in terms of like sides and angles. So we have an angle. In between there we have a side, and then we have another angle. We have angle, side, angle. And if you look at your flip book, angle, side, angle goes with the law of sines. So we're going to use the law of sines. The first 2 are the law of cosines. Goes with the law of sines. So we're going to use the law of sines. The first 2 are the law of cosines. This is the law of sines. And the other day I wrote this out, and I think this was helpful. So let's list it. 63 degrees corresponds to side A. 56 degrees corresponds to side B, and we don't know angle C, so we're looking for that, but we know that it corresponds to 0.5. So these are the things that we have. I feel like I'm missing something. Oh, side angle C. Yes, I'm missing something. Angle C we can get from doing 100 minus 63 minus 56. This will give us angle C. And so angle C is, I can't read my work. I think that's 61, but let me put it in my calculator. 180 minus 63 minus 56 is 61 degrees. So angle C is 61 degrees. That's important. I knew I didn't have enough information. So let me go back here and put 61 degrees in for angle C. What happened? There we go. All right, angle C is 61 degrees. So we have all 3 of our angles. We just need these 2 sides. Now what I'm going to do is I'm going to set up a proportion, and I have to do it twice. The first time I'm going to use this orange information, and I'll color coordinate it. So the sine of 56 over b equals the sine of 61 over 0.5. You cross multiply. B times the sine of 61 equals 0.5 times the sine of 56. We're solving for b, so we're going to divide both sides by the sine of 61, divide both sides by the sine of 61, and we will get our measurement for b. Now, I'm going to warn you, you need to be practicing, let's go to yellow. You need to be practicing this calculation right here. Don't just copy down on your worksheet what I have said. You make sure that you know how to operate your calculator. It's extremely important. So I'm going to put it in my calculator. Make sure you're in degree mode. And I am getting 0.47 for B. So B is 0.47. All right, I have to do it once more. Let's go to green. And this time I'm looking for A. I'm going to use that 63 corresponds with A. And I'm going to go back to this fact. I'm going to use these green facts to set up my second proportion. You could use B, but the problem is if you made a mistake, you're stuck. All right, so I've got sine of 63, over A equals sine of 61 over 0.5, cross multiply. A times sine of 61 equals 0.5 sine of 63. Divide this side by sine of 61. Divide this side by sine of 61. And A is, let's see what A is. I'm going to put it in my calculator. Again, make sure you're practicing this. Make sure you round properly as well. It's 0.51. It's not 50. It would round up and become a 51. All right, that is number 3. How many problems are there? Oh, my word. All right, let's try the next one, even though I just looked at my paper and it's super duper hard. So let's try number 4. I'm gonna have to write really small on this one. What is the problem? I want to change my ink. There we go. All right, number 4. A vertical flagpole is attached to the top edge of a building. Okay, so you've got a building. Here's your building. And then a flagpole is attached to the top of the building. So here's your flagpole. Okay, so you've got a building. Here's your building. You've got a flagpole. Here's your flagpole. A man stands 400 feet from the base of the building. All right, so the man stands 400 feet. Here he is from the base of the building. From his viewpoint, the angle of elevation to the bottom of the flagpole is 60. So if he looks at the bottom of the flagpole, it's 60 degrees. His angle of elevation to the top is 62.5. So he looks at the top, it's a little bit sharper, 62.5. Okay, so if he looks at the top, it's 62.5. If he looks here, it's only 60 degrees. Oh my word, stop. It says determine the height of the flagpole. Okay, so we're looking for the height of the flagpole, and then this is the height of the building. I'll call it B. So there's the flagpole and there's the building. Okay, the first thing we want to do is we want to figure out the building, okay? This is a right triangle, and if we look at this, just this little part right here, let me highlight it in yellow. If we just look at this triangle right here, don't look at the other thing, but just look at, oops, sorry, I didn't trace that very well. This is a right triangle. So since we have a right triangle, we can use SO or CA or TOA. We don't have to use the law of sines or the law of cosines here. How did I know that? Because it's a right triangle. So what I'm going to do, this is my opposite, OPP. This is my adjacent, ADJ, which means I can use TOA for this little triangle. All right, so let's do it. We know that the tan of 60 equals the opposite, which is B, over the adjacent, which is 400. We're just going to multiply both sides by 400. So multiply by 400 here, multiply by 400 there. These cancel. And so if I put this in my calculator, 400 times the tan of 60 is 692.82. That is the answer to the building. It's not the answer to the flagpole, but it is the building. Okay. Let me change colors. Let's go to blue. All right, now I'm going to try to find this big triangle. It's still a right triangle. I now know that B is 692.82. I now know that B is 692.82. I know that. I know that this is F. I know that this is still 400, and I know that this angle is 62.5. So now I'm going to do tan again, but with the angle of 62.5. Okay, so tan of 62.5 equals, now watch this, my opposite, this is my opposite side. This is my opposite. These two together are my opposite. So my opposite is 692.82 plus F. This one's really hard or really fun, depends on your perspective. So 692.82 plus the flagpole is my opposite side, and my adjacent side is 400. Okay, the only difference is I have to add the flagpole. So I'm going to multiply both sides by 400, multiply both sides by 400. Again, I'm using tangent because this blue triangle is a right triangle. These 400s will cancel out. Over here, I have 400 times the tan of 62.5 equals 692.82 plus the flagpole. All right, let's put this in our calculator. Let's go ahead and do that. 400 times the tan of 62.5 is 768.39. And we know that the building was 692.82. And if we want the flag, we're just going to subtract that. So subtract 692.82. And the flagpole is, which I think that's the only question that we were asked, determine the height of the flagpole. Yes. Okay, so we've got 768.39 minus 692.82, and the answer is 75.57. And I think we were talking about feet for the flag whole. All right, I'm going to pause that, look at that really quick, and I'll be right back. All right, let's try the next one. Number 5. Oh my word, this doesn't look fun. I hope this thing is recording. If I've done all this work and this is not recording, I am going to be devastated. So is anybody on? No. Please let this be recording. I'll be so upset. Number 5, on a map, Orlando is 178 miles due south of Niagara Falls. Okay, so here's Niagara Falls. We know it's up there on the U.S.-Canadian border. And it's saying that it's due south, straight down. Here is Orlando. Denver is 273 miles from Orlando. Okay, so we know Denver's kind of like over here. Here's Denver. Hold on just one second. Hey, I'm making a video for my students. All right, so let's see. Orlando is 178 millimeters due south. So this is 178. Denver is 273 from Orlando. So this is 273. And this is, Denver is 235 miles from Niagara Falls. All right, let's see. It says find the angle at Niagara Falls. So we're looking for this. We're looking for this angle right here. Let's call this, well, I'm not going to name it anything yet. All right, let's see. This angle is opposite 273. So I'm going to let this be A. This will be angle A. This will be side B. This is angle B. This will be side C. And this will be angle C. I don't think we need all that, but I'm going to list it out. All right, this is what we're looking for right here. We're looking for angle A. All right, now let's label our parts. We have a side. Oh, no, sorry. We have a side, we have a side, and we have a side. If you have side, 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 you have to use the law of cosines. All right, so this is what we're looking for. This side is opposite it, so I don't know if I said that right, 273. All right, 273 goes here, and then way down here, we put the cosine of A. We do not know A, but we know that 273 corresponds to A. All right, we plug in our other two sides, so we have 178 squared plus 273 squared minus 2 times one of those and one of those. I'm running out of room. All right, this is a calculator nightmare. So I'm going to tell you what this is very carefully. This is 74,529. This is 31,684. And this is 55,225. This is minus 83,660. Now we're looking for A. Remember this, so we're going to have to do the inverse. But we've got a lot of algebra to take care of. Now we're looking for A. Remember this, so we're going to have to do the inverse. But we've got a lot of algebra to take care of first. Next, I need to add these two together. So 74529 equals 86,909 minus 83,660 cosine of A. Do not forget, you cannot just put these together right now. You cannot combine that because of PEMDAS. We have to follow the order of operations. So we got to keep going. This is going to move over and become a subtract 86,909. That's going to be negative 12,380 equals negative 83,660 cosine of A. Divide both sides by negative 83,660, negative 83,660. We're getting 0.14797, and that repeats, that goes on and on and on, equals the cosine of A. All right, now we're going to take the inverse of both sides. So the inverse cosine of the left and the inverse cosine of the right. Those cosines on the right will cancel, and this is just what we need to put in our calculator. So put this in your calculator and you'll have angle A. Angle A is 81.49 degrees. Now, that does not answer the question. The question says, oh, what is that? A? Yeah. Find the angle at Niagara Falls. That's all it asks for. We can stop. I thought it wanted all the angles and we were going to have to do the law of sines, but it didn't. So we're done there. Okay, let me see. All right, we got 2 more to do. Let me get my paper. Hold on just 1 second. Sorry. All right, this is number 6. Nicole shines a light from a window of a lighthouse on a cliff 200 feet above the water. Nick, 10 feet above the water level. Hold on, pull this paper out. All right, Nicole shines a light from the lighthouse. Okay, so we got to get a perspective of what's going on here. We have a lighthouse. Okay, so here's a lighthouse and it's got the stripes on it. Nicole is somewhere on a window. Okay, so let's pretend like this is Nicole. And she's shining a light out of the window. So in other words, she's not down here. She's somewhere up on the lighthouse. She shines a light from above the lighthouse on a cliff 200 feet above the water. Okay, so she sees a cliff. Here's the cliff. Okay, and the cliff is 250 feet above the water. So let's give ourselves some water. Here's the water. And the cliff is 250 feet above the water. So here's the cliff. Nick is 10 feet above the water level. Okay, so Nick, let's change colors. Here's Nick. Nick is like here. This is Nick because we're told that Nick is 10 feet above the water level. I don't know what he's doing, but he's 10 feet above the water level. To a ship offshore. He's on a ship. He finds the angle of elevation of the light is 3. So Nick finds that this angle from Nicole to him, whoops, sorry, that's not straight, is 3 degrees. Now that picture is really, 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 really confusing. Look at that, really good. All right, the picture is harder than the problem, to be perfectly honest. All right, we can make an assumption that these are right angles. And so we have this triangle right here. It's a right triangle. and all we are looking for is, it says find the length of the line of sight of the light beam from the ship round to the nearest. Okay, so the light beam to the ship, here's Nick, so we're looking for this side right here. This would be the light beam to the cliff. It said the light beam, which starts at Nicole and goes to Nick, which is on the ship. All right, so this is not a complicated problem. This is going to be, we have a right triangle, so we can use either so, ka, or toa. How did I know that? Because it's a right triangle. If you have a right triangle, you can use one of these basic trig functions. If I look at my angle, I have my opposite and find the length of light assigned from the ship to Nicole. And this is my adjacent. Wait, that's my opposite, and this is my adjacent. Now, to be perfectly honest, I'm kind of questioning myself on this picture right here. Let's see what we get. So the sine, oh, sorry, not sine. Opposite over adjacent is tan. So the tangent of 3 degrees equals 250 over x. We don't know what the length is. Multiply both sides by x. This will cancel. We've got x tan of 3 equals 250. Divide both sides by the tan of 3. Divide both sides by the tan of 3. And let's see what we get. 250 divided by tan of 3. I'm getting 4,770, what are we talking about, feet? Yeah, feet. I think that's too big. Okay, I think that's too big. If you do that yourself and you get a different answer, let me know. I think that's way too large. But we've got one more to do, and then I'm going to stop this collaborate. I'm trying to find my answers to this section, and I honestly just cannot put my hands on them right this very moment. So, like I said, if you disagree with me on that, let me know. But let's do the last one. I'm going to start. The last one is number 7. Let's see. Number 7. Sorry, that's sloppy. Number 7. Fire towers A and B are located 10 miles apart. Okay, so you've got fire tower A and fire tower B, and they're 10 miles apart. Okay, so you've got fire tower A and fire tower B, and they're 10 miles apart. Rangers at fire tower A spot a fire 42 degrees away. So these people see the fire, here's the fire, at a 42-degree angle. Tower B spots the same fire, at 64 degrees. How far from Tower A is the fire? Okay, so we're looking for this length right here. Let's label what we have. We have an angle, we have a side, and we have an angle. And based on our information on the flip book, angle side angle is the law of sines. All right, this is a good one to end on. Now let's label our parts. Okay, so this 42 corresponds to side A, this corresponds to side B, and this final angle, let's see what it would be. What's 180 minus 42 minus 64? That would be 74. So this angle is 74 degrees. This is 74, and this will then be C. Now I'm going to write those corresponding parts out. So 42 corresponds to side A. 64 corresponds to side B, and 74 corresponds to side C. And all we're looking for is B. Well, we know side C, so it's 10. Let me put a 10 right there. All we're looking for is B. This is what we're trying to find right here. So we're going to set up the law of sines using this information. They don't even ask you to get the third side, so you don't have to do that. So we're going to do sine of 64 over B equals the sine of 74 over 10. We're going to cross multiply. B times the sine of 74 equals 10 sine of 64. Divide by sine of 74. Divide by sine of 74. B is, let's see what it is. I don't have the answer. 10 times the sine of 64 and press enter. Divided by the sine of 74 and press enter. 9.35, and the worksheet says to the nearest tenth of a mile. This is the 10th place, so it would be 9.4 miles away. All right, I'm going to stop this collaborate, but I want you to check number 6 for me. I feel like that number is too big. So if you'll check number 6 for me, maybe my picture was wrong, maybe I misread it, I don't know. But watch the video, make sure you have these pages taken care of before we return to class.